you are like working on some IoT devices and you want some connections to be made. So we'll be mainly talking about those issues and how to get a workaround solution for that issue. So, so as I would, like I mentioned, so our issue is with WebSockets. So if you are aware of WebSockets, those are like persistent connections on top of HTTP. So HTTP is like you send a request, you get a response, it is closed, done, completed. But WebSocket is like you send a request, you send an upgrade, and you remain connected until unless a server ends the connection or the client terminates the connection. So here we face a lot of issues, like when you want to push it up, you want to scale it up, then you face issues because of the hardware resources and those things. So moving ahead, little about myself. I work in TCS for a client project. I'm a principal front-end engineer. So my main work area is like from the front-end applications. I build those and for the like our client. And apart from that, in my free time, like the time post office, I work on the like my hobby, which is mainly robotics and building things, like not just specific to robotics, building anything. So you can be like, it's more like you can, from my point of view, if you are not an engineer, if you don't know how to build stuff, because if you look at something, the first instinct that should kick in is how it is built, or what parts are used, or what we are using in it. So that is what drives me for my free time and the things what I do. So introducing my co-speaker, Mr. Pratik.
Hi everyone. Quite a number of faces I can see here. I'm nervous as well. Can you guys give me a cheer? Help me out.
Can we have a cheer for him?
That's better. A brief introduction about myself. I work as a freelance Android and web app developer. And there's a long story to how I ended up as a freelance. Anyways. Also, I'm a Marvel fan, a hardcore Marvel fan.
How many Marvel fans we have here? DC
Captain
fans?
America fans, give me a cheer. Captain America fans. Come on, guys. Iron Man is better. Iron Man is better.
Yes, we are engineers. We would love Iron Man more than Captain America. Any DC fans? Okay, good, good.
Someone said AC/DC. So, next one.
Okay, so starting off, you might be aware, like for IoT devices, the main purpose is data collection. Like with the devices which we have as endpoints, they mainly collect the data. It can be your sensors, like light sensors, how many times you are entering, leaving, or camera data, video data, audio data. There are a lot of types of data which we can collect. So moving ahead, so like the data collection sources, we need some devices which can collect those data. So as you might be aware, like for the input devices, we have microphones, cameras, or some sensors, like you have PIR sensor and other things. You might have automated things like when you enter a room, the lights are turned on. When you exit it, the lights turned off. Apart from that, we have smart bulbs, plugs, thermostats, ACs, locks, camera. Nowadays, like basically you have a water bottle that is also a smart water bottle. It will monitor your temperature, how many liters of water you're drinking, those things. So from Google, we also have some things like Nest, Nestcam, Chromecast. They also are part of the smart home application. Apart from that, we have Google-supported home automation devices like by Philips, Honeywell, Waze, Xbox, Samsung. Like there are millions of devices. If you go to the Google skill adding section, you'll see a whole list of devices which you can pair up with your Google Assistant and use. So these are the production-based which are made by companies. Now there might be some query like I want some personal device to be made, typically for myself. So I made one of them, so I've installed it in my room. So basically it's a simple automation system for the room applications like light, fan, AC, etc. So this was based on the Node MCU. So it's a microprocessor, microcontroller, that family it comes from. And then apart from that, we have smart LEDs, which you can make. You can make RFID based things, you can make locks, nowadays you get smart fans also based on BLDC. You connect with Alexa or Google. After you can go to the Google Assistant and then ask it to turn it on, off, change the speed, everything. And we have smart custom-made modules also, which we make. Apart from that, these are all the things which we make out of Raspberry, Arduino, then ESP32 family. You get the microcontrollers and things, and you make out. Now, this building of thing is what is your capability. You can take it, scale it up to anything you want. You can build literally whatever comes to your mind. If you want it on the internet, you can build it up. So it's all about how much you want to deep dive into it. So moving ahead, so next topic I would like to discuss one is the first thing which comes up is an MQTT. You might have heard when we are using any smart devices or anything, we use the MQTT type. So MQTT is basically a pub/sub system that is typically built for small scale devices where you don't have a big processor, a big RAM, you don't have those things. So you need something small but useful. So we use MQTT in those systems, and we have WebSockets also. So they are like if you go to a ground level and do a deep comparison, like MQTT and WebSockets are not directly comparable. You cannot just compare them directly, but they are something similar in nature. You can say both have a publish subscribe system, and both runs on like a continuous ping pong type of thing. So if you see WebSockets, is an environment, so it mostly supports the pub/sub architecture, and MQTT is a pub/sub itself. So one is an architecture, and one is a solution type. So apart from that, we have like basic Google differences you can see. So these are all taken up from Google only. Okay, many of them I also learned it lately while making the presentation. Okay. So MQTT is mostly designed for IoT devices. So what we want here is we want to go something which we have control over. MQTT you cannot control. If you are using a third-party application like the MQTT provider something, you cannot tailor it according to what you want. So we will move to a more we can say generic type which comes in form of WebSockets. So WebSockets, you are the master. You do whatever you want. So next is moving ahead, we will be discussing the scalability of WebSockets. Like suppose you have one device today. Tomorrow if you go to production, you'll have 1 million devices. Now 1 million devices you cannot connect to one instance or one server. You need to scale it up. And WebSockets, we have this very big difficulty of scaling because you need persistent connections. You cannot break them in between, like HTTP. Suppose if you send one request, response, that is done. You change the server before the next request comes in, you can do that. But for WebSocket, you cannot do. As long as the connection is alive, you cannot change the server. If for some reason the connection goes down or the server goes down, the connection will terminate. So the user will be affected. For HTTP, you might see a small downtime. Once the server is up, you can get it back. So moving over to, I'll hand over to Pratik from here. He'll be discussing about the WebSockets and the things related to it and the scalability issues and what we can do about scaling it.
So how many of you have worked on WebSocket-based applications before? Can you raise a hand?
Very few.
So it's not only two of us, there are a few.
Yes.
Anyways, scaling WebSockets for IoT devices. But the question must arise, why WebSockets? I mean, there are so many protocols like TCP. You have the massively used protocol named HTTP and MQTT as well. And MQTT is a protocol which is designed specifically for IoT devices. And it's a publish-subscribe protocol. But despite that, why are you going with WebSockets? To understand that, using TCP sockets is recommended only when you have like a requirement for building a proprietary protocol. Or maybe you are living under a rock because you like reinventing things. I mean, why to reinvent the wheel when you already have so many options for IoT applications? The MQTT protocol can either operate over HTTP. I mean, the underlying protocol can be HTTP, TCP, or WebSockets itself. But still, the problem with MQTT is that MQTT is a pub/sub protocol, and it adds a lot of overhead on the underlying protocols, like the quality of service and a lot of stuff. And also, we want a point-to-point communication between the IoT devices and the server. And as shown in the previous slides, the number of applications that Bhaiya described, we may need a point-to-point communication protocol in that case. Now, making multiple HTTP requests can be a possible solution, but in that case, that would impose a lot of CPU and memory footprint on the IoT devices because the amount of RAM and CPU is very limited. It's around 512 kilobytes of RAM, and you're making HTTP requests constantly. So there wouldn't be any room left for any other task and processes in the IoT device itself. So now let's understand what WebSockets are and how do they work. So WebSockets are pretty much like an upgradation to HTTP request. In order to instantiate a WebSocket connection, the client sends an HTTP request, a GET request to the server, and that request includes two special headers. Number one is connection upgrade, and upgrade is WebSocket. These are the two headers. There's a constant negotiation that goes between the client and the server based on security and stuff. We will not go deep into that. And if the server responds with the headers, with the same headers, we now have a successful connection. Now, the problem with WebSockets is that they are hard to scale. Now, HTTPS can be represented as a clap. So let's say this is a server and I'm the client. I have to make 6 HTTP requests within 3 seconds. So 1, 2, 3, 4, 5, 6. All 6 requests done. But WebSockets look somewhat like this, 1 and 2. What about the rest 4 requests? They cannot be instantiated.
You are kind of locked here. You cannot move ahead until this is completed.
Also, there's a limit to the number of concurrent connections that can be maintained between a client and the server. So we'll come more to it. So as a conclusion, HTTP requests are stateless and WebSockets are not, obviously. So let's now see if there's a workaround for scaling WebSockets. Okay. Now, as I said previously, there's a maximum limit to the number of connections that a server can handle. The total number of ports available in any Linux machine is 2 to the power 16, and the usable port is around, starts from 1024. Boring tha kya?
Okay, 2 to the power 16, what is the value? Can you tell me? Till the slide comes up? Okay, it's
Okay.
it came before the solution.
So that's the total number of TCP connections that you can theoretically achieve with a machine. But achieving that number of connections is a very difficult task. It's like you're maintaining multiple connections to the Mars rover. It's as difficult as that. In fact, in 2012, WhatsApp achieved a milestone of connecting 2 million TCP connections to a server. And that required the single server to be run at 35 gigabytes of memory and 24 cores in 2012. And we are in 2021 right now. Achieving this many connections is obviously costly on the resources. It's very expensive. Now, how to scale WebSockets? These are the possible solutions that you can use. First is the app engine, that's the serverless approach. Second is the cloud run. Well, the difference between them is, for app engine, you just simply create your node app and you are deployed to the app engine, and app engine takes care of it all. But in the second case, you can containerize your application and deploy it to cloud run.
So it will be mostly like a CI/CD pipeline. You deploy your code, the cloud run will pick it up, and the server will be created according to the configurations which you have set.
Now, if you are a microservices freak, you can also use GKE clusters, Kubernetes engine.
So Kubernetes, you might be aware of the container things which we do for deploying microservices, those things. So Google provides a solution for that type of architecture also.
But we would also like to demonstrate, give a live demonstration on how we have managed to scale WebSockets. Now, we do not have 1 million devices, IoT devices here, but we'll tell you how we'll demonstrate it.
So before...
sorry, that's not a demonstration.
Okay, we'll skip this part due to the time, but I'll tell you in short. So WebSocket and Socket.io, you might be heard, like it's a very common thing. But if you see in Postman or providing the things, there they mentioned WebSocket and Socket.io as different type of thing. So Socket.io more or less serves the same purpose as WebSocket, but it is more production based, like you don't have more control over it. You can see it has auto connect, namespaces, room subscription, and lot of things which you might not need in an IoT case. So Socket.io is good for some applications, but for IoT application, we would prefer WebSocket. We'll have more control, we'll build what we need and how we need it.
And so also for every WebSocket connection that you make, it requires almost 4 to 6 kilobytes of memory. But if you do that the same with Socket.io, it can take up to 18 kilobytes of memory. So for one connection, if it takes 18 kilobytes, for 1 million, it will take a lot. So we'll definitely go with the native WebSocket library the Node.js provides.
So for past few days, we have been up all night building a small application for you guys to interact with. So I would request all of you to take out your phone and with the possibility of a QR code scanner. Or you can open Chrome and then you can go for the IP address which is mentioned there. You'll get a web page similar to this one, something like this, but the device ID will be different. So if you can. So as you connect, you might be getting a notification with a device ID, an alert box on top.
And what happens is that as soon as you open the web application, a WebSocket connection is instantiated with the server. And
that device ID is basically the ID which we are using to connect to a WebSocket on the server which is running on the cloud. So if you move ahead, you'll see a send button with a select card button with a green thing. I would ask you to select one card. It will generate a random card and send it to the server. We would have loved to show you the server response, like whatever cards you are sending, it will be all listed like this, message received, like that whole list. But since the cloud thing is not like running on my laptop, I won't be able to show you. But the response would be something similar to the screenshot which is over here. And if you click on get active connections, you'll be able to see who all are connected on that particular, like all the list of WebSockets which are created. So as many of you are created, you'll be able to see a whole list of like active connections present there. If you, you might need to scroll it up also if you have enough connections. So this is how like the state of the device, like you are connected to us, that thing how we maintain. So it's a small, like the main part of the code we will show you. There's a lot of wraparound like UI and HTML. We don't want to get into that. So we'll just show you the simple working, like what is in the client end, what is in the server end. Okay. So client end, if you can see, the line starts off with generating a random string. So that random string is basically a device ID to uniquely identify you. Next is we create a WebSocket instance. So that will be a web server API where we are like actually sending the request. So that will be a like a Google instance, VM instance, on which we are sending that request. So you can see after that you might have gotten that alert connection established with device ID. So that was the alert which you got. Then moving ahead, like when we like kill the server, or when the server stops, or when the thing terminates, you will get something like connection closed cleanly, and then you will get a code and the reason. That will be sent from the server, or you will get a connection died. So based on whether it was killed from the server or there was some problem. So moving ahead, so on the server side we have something similar. So we are like listening to your part. That will be like the bottom part of the code, WebSocket server.on connection. So here is the place where we log the whole thing, that what card has been sent by each of you. And on top of that, you can see there are some extra APIs which we are using. So we'll show you like what that API use is looking like. So that active connections API is actually that get connected, the below button which you are seeing, on click of which you could see the whole list of active users which have connected to the API. So that will be the /active connections API. So now the question comes in, how did we achieve this thing? Okay, and how are we scaling it up? Okay, so first of all, what we did, so this is a very high level understanding. We are not like going very deep into it. If you want to know, you can always come up to us. We'll explain you deeply how we did it. So starting off, we created a single instance, and it is running on a single port. So we have a limit, as mentioned before, to the power 16. Now, for that, for what happens if you want to scale up, you need multiple instances. You cannot have it on one instance. So we have something called MIG, that is Managed Instance Group in Google. What it will do, it will manage multiple instances together. So all the scaling parameters and everything, we added to this MIG part. So MIG will take care of that. Now next thing comes in, when you have multiple instances, you'll have multiple IPs. Now you cannot tell one IoT device you connect to this IP, another one you connect to this IP. So you need a reverse proxy or a load balancer. So we have solutions like Nginx, HA proxy, you might have heard of it. But the problems are, for Nginx open source, if you're going for a free type of thing, you need to first run the server, then connect with Nginx open source. You cannot scale it dynamically. You have to have all the servers running, mention the Nginx, like these are the things we are using, and then move ahead. Nginx Plus offers this dynamic thing, but it comes at a very huge cost. You can see it's almost $2,500 a year. That's a huge cost for small scale businesses. Enterprises might manage it, but for small scale, it will be a huge cost. Then we have HA proxy. It is on MIT license, so it might not be favorable for enterprises. They will look for some licensed stuff. Because MIT license are like anything can be uploaded, there may be vulnerabilities or something.
Demonstration. Demonstration. So as we can see here, total of 18 devices are connected, still connected. Can we have more number of connections, please? I want to broadcast
Is anyone
a
who got
message
disconnected?
to all of the clients.
Okay, there are few number of, if you refresh it, you will be able to reconnect back. You just refresh the web page, you will be able to connect
Yes, it's
again.
increasing, 21 connections. It's 28, well,
31.
scaling really fast, 31. Come on, or.
और क्या है? बाकी कहाँ है सब?
37, yes.
Do we have only 37 people in this room?
40.
40.
40 connections now we have. 45, great. Share these to your relatives as well, they can connect.
Yes, it's on open internet. You can send it to
And
your
that's
friends via
scalable.
WhatsApp.
It's scaling to 52,
People in the Mac 2
51.
room, you can forward
Okay.
it to them. They can connect
If
here.
you carefully observe the web app, I'll share a message.
You'll get an alert in some time. If you see the web app, you'll get an alert.
How many of you did you receive?
How many of
Hello.
you received an alert? What is the alert? Hello. Only hello.
Okay.
Give something else.
Welcome to What about this?
What you got now? Welcome to
Okay.
CCD call.
Now let's try something else.
You'll get to know something about Pratik. What do Arey.
Just kidding, guys. That's not true.
Okay, so this is how a subscribe thing works. So by one click from here, we can notify all the IoT devices about some status or some promotion. If you want something to be updated, some data to be transmitted, you can just give a broadcast, all the IoT devices will receive. Now, here for an application, we couldn't show you IoT device because everyone, they don't carry IoT devices around. So for a simple application, we showed you with a web app. Now, instead of a client end on the web app, we will have some IoT devices there. Node MCU, ESP32, anything based on it, which will be connected to the internet and will behave in a similar manner. So further enhancing, we would like to mention the four major things which we used here. So first one, as I mentioned, MIG, Managed Instance Group. Moving ahead, we use the load balancer. Load balancer, as I told, like you have Nginx, HA proxy, you might have some issues. You might have costing, but Google gives it for a little bit affordable thing. So you have the load balancer, TCP/L4 load balancer. Then for the memory store, the data which you are storing, we are collecting it in the Redis API. That is also provided by Google. And then we are using cloud monitoring to monitor how many connections are there and how we are going to scale it up.
Now, talking about all these services, let's talk about how are these services connected. So can we open the console?
So if you can see here, there are two instances running as of now. We have the so if you can see here, this is the beginning when we page refresh. So the page is refreshing actually. So we gave a scaling factor. So that would be responsible for scaling the VM instances. As you saw, there were only two instances. One was a monitoring instance. You can ignore it, like it's just for monitoring purpose. And then the second instance was the primary instance on which every one of you started connecting. But after some number of connections, that scaling should happen. It should create a new instance and then redirect the new users to those instances. So how many kitna connections were? Okay, I think so the net is lagging as usual. Geo has gone down these days. Anyone using Geo? Who all use Geo? Only this many. Geo users.
Airtel Zindabad.
Airtel Zindabad. Free नहीं रहा.
But speed देता है यार.
क्या feel? ये feel. Okay, so basically, like after loading the page, what we expect you to see.
Yes, here we go.
See, yes, finally, you can see two more instances which are created. So we gave a scaling factor of small number, like around 20, 30. So as the number of connections crossed 30, two new instances got created. So 30, then 30 again. So
Let's
as you got
hide the
connected,
IP addresses first.
Okay, IP addresses were visible. Okay, we don't want any like one to.
Anyways, that's
No, it's okay. You can ping those internal IPs. We are very vulnerable people. We expose everything to outside. Okay. So you can hit these IPs also directly and get the data. Though we would not recommend in production because that will be very bad for your application. But we do bad stuff.
Now let's talk a little bit more about how all of this is being connected. See, the total number of connections that we recorded so far was 63. And we have like set the limit for every instance. The maximum limit set for every instance is 20. So based on that, we have 3 instances being created, as you can see. Now, if we go to the metrics over here.
Again, metrics will take time to load. Time take a load on them.
Same issue. 3 minutes left.
Okay, we can blame the internet for not showing you the things. Okay, but we would love to show you. So might be like when we share the presentation or the slides with you all, we'll try to include these screenshots as well once we get a faster internet connection. If Geo gives.
I think we can.
Okay, every time we can blame the internet, it will come back.
Overview, metrics explorer.
Metrics. So please, every one of you blame the internet. It will work faster.
क्या इंटरनेट यार?
जाके पोर्ट करा लेंगे. Okay, while the metric comes up, so if the metric comes up, you'll be able to see like how many active connections we are having. So monitoring metrics is the main part. Like we have the.
Can I connect this to my device so I can show it better?
Okay, we are having a device transfer.
Okay.
New instance. Older one is having problems. So we have a new instance connected with no signal. Okay, red. Hey, this is not Google color.
Oh.
Extend हुआ है.
Oh, okay.
तुम्हारा default extend किया हुआ है ना. So you will see something slide in from side.
Okay, there we go.
Something came up. So here you can see he is also like watching the whole
Linux
thing.
is unpredictable at times. Yes. Anyways, we still have.
We still have those
many
3 instances running. Now, once when you start getting disconnected, those instances will get they'll start closing up. Like they will scale down. So we have a scale up and scale down feature. So when you have more number of connections, it will scale up. Once the number of connection decreases, it will scale down. So we have that resource, like you will have resources what you need. You don't have to overpay, you don't have to underpay.
Go to monitoring.
Full screen
If we open the
full
metrics.
screen karo, full screen karo. Maximize.
Maximize karo, but one second. Monitoring and metrics.
Matrix
Explorer.
Explorer. Okay. So we are getting the Matrix Explorer. What internet you are using? Airtel Zindabad.
239 maybe. Okay, so here we have created our own custom metric.
So you can see
Basically,
here.
the monitoring server that you saw, what it does, is it counts the number of connections to every instance. And based on that, it publishes that to the metric. Now, the managed instance group, which comprises of, which is responsible for scaling, basically keeps a watch on the metric, on the number of connections being created, and based on that, it scales or creates number of instances inside the group. So if we go to custom here, total WebSocket connections, and go to apply. Let's see if that works. Okay, so we did reach a peak number of.
Around 60 connections.
Okay, that's not the correct.
Agree.
Instead of
Okay,
mean,
it's
we'll go
mean,
to next
next
folder.
folder.
I feel like a hacker, man, operating like this. Anyways,
Okay, we again have a drop. We almost crossed 60. That's a good 63.
instances.
Good, good.
And that is how we scaled the number of devices.
So
and
as you saw the scaling which happened, so from one
we
instance.
still have 10 devices connected. Kaun hai?
Ping, ping, ping. Ping karo.
You guys are loyal.
बाकी सब बंद कर दिया Chrome. Net खा रहा
Okay,
है.
so due to the time constraint, we had to wrap this up. Any questions do you guys have? So many questions.
Okay, we'll be taking them one by one.
Easy pushna.
I am Arjo. So
Hi.
I have a question like, I understood like basically HTTP was dependent upon the TCP protocol and this WebSocket is dependent upon the HTTP or HTTPS protocol.
Yes.
So basically like whatever security is provided for the HTTPS and this TCP, so for WebSockets, I mean, are we going to do something for the security or that is been taken care by Google Cloud?
Okay, so for explaining this, let me explain how WebSockets work. WebSockets can be thought of an upgradation over HTTP. It's basically HTTP, but we are maintaining the connection for a longer period of time because HTTP is stateless. When you make a request, you get a response, and the connection remains for a very short amount of time. So that's a stateless connection. But in case of WebSockets, it's pretty much the same. So all of the security and all of that, that is application layer 6. If you understand the OSI layer, right, TCP operates at layer 4. But talking about the SSL encryption and all of that, that is precisely application layer 6. And HTTP was built on top of it. Now MQTT and WebSockets, they also lie in the same layer. So which is why if you are using HTTP, you are using WS as the prefix for making a connection to WebSocket server. But if you use HTTPS, you replace the prefix with WSS. Right? So this was running an HTTP server, right? WebSocket server, which was not secure. Now, when you make a request from the application, it was making an HTTP request, right? So the URL for that WebSocket URL server starts with WS. Everything remains the same. Instead, in fact, if you want to connect to the server, you can also make a request by entering the parameters and headers and a lot of metadata, just like you do in HTTP. You can do that as well.
Thank you.
So many questions. Let's accept limited questions only. Let's give room to other speakers.
One question I had, like, what you did, like, you created many more instances and handled the traffic, right?
Yes.
So, for example, so every socket has a socket ID, right?
Yes.
So, for example, one instance, like one socket had a connection with instance 1, and then the another socket has a connection with instance 2,
Yes.
but they want to communicate internally. It's like you want to send message from socket 1 to socket 2. So how are you modeling this one? Are you using any external data, like in-memory database or something to, like, another issue, it might happen that your instance goes down and then it will come back online. Then how are you handling this scenario?
Okay. So for answering your question, we just did a broadcast right now, right? And we did it from the monitoring server. But when you were scaling, right, most of the users were, the traffic was distributed to multiple instances, right? So how did the message reach to each one of the instances and then to all of the clients? Well, we are using Redis API in this case. We are using Redis cache.
So
basically, Redis PubSub. So there's a topic called broadcast, right? If instance 1, let's say for any other external instance, publishes data to that broadcast channel, the multiple instances inside the group they are subscribed to the channel. So let's say if there's any message, they will react to it, and based on your application logic, you can either process a request or maybe send a broadcast to the client or do whatever you want.
So it's more like multiple devices on a same YouTube channel. So once something gets posted, all the devices, they get the notification. A new video is up.
We can create our own YouTube. by the way.
Okay. YouTube.com. Yes, yes.
Yeah. Hi, this is Dayapayan,
Hi, Deepan.
system engineer at TCS.
Okay, good.
So, as you were showing that all of the devices are getting the same notification and this is
Yes.
from different sockets.
Yes.
So, what if, like in an actual IoT project, since we have different IoT devices with maybe the same sensor posted in different places, and they may be reading different data, and maybe they are using the same socket at one time. So, depending on the data that they're receiving, with your UI has to send different notifications to each one, or maybe process the data in a different way.
Yes.
So how is that being handled?
So
if
as
it's
of now, we are using only one API. So if you might have, it would not show it on your web app, but we are using a /echo. So if you want multiple requests, multiple responses, types of response, you can always change the API. You might have a /echo, /broadcast, /record. Someone using the /record channel, someone is using the /echo channel. So when you promote it to the /echo channel, all connected to that will get the response. If someone is getting on some other channel, they'll get some other response. So like that also you can configure. It's all about how you build your backend. If your backend is able to handle multiple responses, you can have it well and good.
Yes.
If you want like one master broadcast channel, you can have a master broadcast channel irrespective of what API you're connected to. You'll get a whole response to all the APIs or whatever is there.
Let's keep it short.
So depending on the number of IoT devices I have, so I will have to have managed, instances for every single devices differently.
No, instance are a copy. Instance are
Okay,
a
yes.
copy of each other.
Yes.
So whatever is running on one, it will same thing will run. The only
Okay.
thing is that you for one, like it's more like if you go to an event, if 100 people come up to you for your autograph, then what you'll do? If someone can copy your autograph, you can route 50 people here, 50 people there.
Okay, yeah.
So what will happen? They are both getting the same thing, but from two different sources. So from the client perspective, I just want my thing. From where it is coming, it's not my headache.
Okay.
Okay. So if I get the data correctly, if I get connected correctly, my work is done. It's well and good.
Sure.
Okay.
Anyways, guys, we will accept any more
Thank you.
questions outside. And apologies to the next speaker for taking up your
Okay.
time.
So we'll be sitting here only. Okay. So during lunch break, whole of the day we are here. Whatever queries you have, you can ask us, as we are already running a little late.
Sir,
Okay.
one last question.
Okay. One last question. Okay.
Sir,
Okay,
I want
last
to
one,
ask
huh?
you here. I want to ask is right now there are only few connections are here.
Yes.
So how can Google Cloud help me if I close this connection? Suppose this is closed from there.
Okay.
But how can Google Cloud help me to track the history what are the devices connected and what are the IP addresses of
There's a logging service which is available. Okay.
Okay.
Under Google Cloud.
Okay.
Using the logging services, you can just log the whole number of connections. We are just monitoring as of now. We are not logging anything. So if you log the connection which is coming in from which IP, which device ID, you can log the whole thing to a database, to any metric,
So
anything.
even if the questions, even
So-
if the connection gets closed,
Even if the connection gets closed, there are two possible situations. Either we would not recommend in an IoT field to send back the connection. You will always wait for the client to connect to you. If there is a termination also, the client will try to connect back. Okay.
okay. Thank you.
Okay, guys, thank you so much. I would like to wrap up this session with a humble thanks to all the organizers. You guys are doing a great job.